What is data science? Rise of the spawner recruit models from a developer point of view. Rise of the recruit spawner models. Spawner recruit models. Spawner recruit models is a basic relationship between the number of healthy parental units of species and the number of new units in a group in the public dataset of numbers of salmon spawners and recruits. The following graph was formed to visualize the relationship between the two. We can see that there are definitely some sort of positive relationship. As one goes up, so does the other. Recruits equals 0.5 times the spawners plus 60. Yes, visualization of spawner recruits. This is the visualization of the spawner recruits. Hierarchical clustering. Partitioning can be visualized using a tree structure. A dendrogram does not need the number of clusters as input. Possible to view partitions at different levels of granularities. Can refine such coarsened clusters. K-means clustering cost function asks to minimize the sum of square Euclidean distances of data points to their closest prototype center. K-means cost function seeks to compact global clusters of small variances. The cost of a single cluster is minimized when we choose for the cluster prototype its center mass C, called the centroid. K-means clustering, where G denotes the cardinality of G, that is the number of elements contained in group G, and argument M f of x to denote the argument that yields the minimum in case of the minimum value is unique. K-means clustering. Instead of choosing the squared Euclidean distance, we have to choose the ordinary Euclidean distance if one obtains, so we call the Beament-Webb pointer that generalizes the notation of the median, thus called the geometric median. Although Fermat-Weber point is unique and often is used in operations research for facilities location problems, it does not admit to a closed form solution but can be arbitrarily finely approximated. K-median clustering is the clustering obtained by minimizing the cost function. K-means clustering, where means the Euclidean distance. The partitioning from K-means and K-medians can be different from each other. The centroid location can be different to the median for a single cluster. K-means clustering. Centroids can be easily corrupted by adding a single outlier point. We say that the breakthrough point is centroid 0. A single outlier P diverging to infinity will impact the centroid Therefore, k-means clustering is often preferred when there are many outliers in the dataset. K-clustering graph. This is the clustering. This is the clustering graph. K-means problem. Given n-points in d-dimensional space, x r to the power of d, point set with x of n, partitioning x into clusters. Assign each point to x of I to the common center, IC. Goal, minimize the summation of I. K-means clustering is a fundamental problem in data analysis and machine learning. By far the most popular clustering algorithm is used in scientific and industrial applications, identified as the top 10 algorithms in data mining. K-means clustering. This is a visualization of K-means clustering. K-means optimization problem. Finding the center of a single cluster is a particular case for clustering with k equals 1 cluster. If the square Euclidean distance across the center is the mean of attributes, hence naming k-means. Finding the minimum of k-means cost function is NP hard problem when dimension d is greater 1 and the number of clusters k is greater than 1. When k equals 1, we have to compute the optimal solution, the centroid in linear time, computing the means. When d equals 1, we can compute the optimal k-means solution using dynamic programming. Using O of nk memory, we can solve k-means for n scalar values in time. O of n2k for NP hard problems. We seek efficient heuristics to approximate the cost function. We distinguish two classes of such heuristics. K-means optimization problem. Global heuristics that do not depend on initialization. Local heuristics that iteratively starts from a solution of partition and iteratively improves its partition using pivot rules. Computer programming. Computer languages are how we communicate with the machine and tell it to do our own bidding. A computer speaks many languages, and like a book can be written in many languages. Similarly, data science can be done in many languages. Python, Julia, and R are some of the many languages available to us. Why Python is the best for data science? Python is extremely simple language to read and write, even if you've never coded before, which will make future examples easy to ingest and read later on. Even if you have completed this module, it is one of the most common languages both in production and academic settings, one of the fastest growing in a matter of fact. The language online communicates vast and friendly creatures of algorithm. This means that a quick Google search should yield multiple results of people who have faced and solved similar situations. Python has pre-built data science modules that both the novice and veteran data science can utilize. Python modules: Pandas, scikit-learn, Seaborn, NumPy, Sakai. Request to mine data from the web. Beautiful Soap for web HTML parsing. Lloyd's batch k-means local heuristic. Local heuristic, if I'm given an initial input equals x of 1 rd, the number of partitions. Initialization start with k centers typically chosen uniformly at a random from data points. Iteratively repeat until convergence is the following step. Assign points to the clusters. Each is assigned to its closest cluster center for each for each, let's see, x1, and define the K cluster groups as GJ1 with the defined and the number of elements of X falling into the J cluster. Update centers for all J's. Update the centers to their centroids. Years. A possible convergence criteria. Cluster centers do not change anymore. Krisha. Heuristics. Lloyd's method evolves in 1957 and remains an extremely popular heuristic to start with K initial seed center C1. Iterate the following Lloyds have assigned each point to the nearest center C to obtain the clusterings X1 to XK. Update C1 and update that. Choosing the number of clusters K. Recall that K means this is AK sum of distance of points K from their cluster centers. One way to select the number of clusters K is to try different values of K. Plot the K mean subjects versus K. Choose the elbow point. One drawback of this method is to computationally very expensive sometimes, depending on the data sets. The inflection point between the sharp decrease and the plateau is not so well defined. Choose the number clusters K. For the plot to the left, K equals 2 is the elbow point. Initializing issues. K-means is extremely sensitive to cluster initialization. Bad initialization can lead to poor convergence rate, bad overall clustering. Safeguarding measures. Choose the first center as one of the examples. Second, which is the farthest from the first. Third, which is the farthest from both, and so on. Try multiple initializations and choose the best result. Other smart initialized schemes is look at the K-means plus algorithm by Arthur and Vasilevsky. Limitations illustrated. K-means might not find the best possible assignments. Analytics is a broad term that encompasses is projects, technology, frames, and algorithms to extract meaningful insight from data. Analytics is the process of extracting, creating information from raw data, filtering, processing, categorizing, condensing, contextualizing data. This is information that is obtained and then organized, structured, and for knowledge about the system or its users, its environment, and its operation progress towards objective, thus making the system more smart and efficient. Purpose of analytics: to predict something, to find the patterns in the data, finding relationships in the data, computational tasks, basics, generation and body problems, linear algebraic computing, graph theory computations, optimization, integration, alignment problems. Descriptive analysis comprises of anything past data to present it in a similar form, which can be easily interpreted. It explains that a major portion of the analysis done today is description analysis through the use of statistics. But descriptive analysis is useful to summarize the data. Diagnostic analysis comprises of analysis of past data to diagnose the reasons as to why certain while descriptive analysis can be useful for summarizing the data by computing various statistics such as mean, median, minimum variance, and top end. Diagnostic analysis can provide more insights into why a certain fault has occurred based on the patterns in the sensor data or previous fault. Predictive analytics comprises predicting the occurrence of an event or a likely event or forecasting the future values using prediction models. Predictive analytics is done using predictive models which are trained by existing data. These models learn patterns and trends from existing data and predicting the occurrence of an event or a likely outcome of an event or forecast them. This accuracy of prediction models depends on the quality and volume of an existing data available for training models. Prescriptive analysis. While predictive analysis uses prediction models to predict the likely event, prescriptive analysis uses multiple prediction models to predict various outcomes and best course analytics, and for each prescription analytics can be predicted possible inputs based on current choice factors. We can consider prescriptive analysis a type of analytics that use different prediction models. Prescriptive analysis prescribes the actions or best opinions on the following available types of analysis: description analysis, diagnostic analysis, predictive analysis, prescriptive analytics. Big